The CLO for this lesson is that students will be able to solve in writing for x using multiplication and division, as well as the following language: if-then statements, isolate, inverse, and eliminate. So, in your own words, what do you think you're going to learn how to do in this lesson? If we begin with the vocabulary, the word isolate, remember, is just the big word to mean get alone. So, like if you're isolated, it means you're all alone. So, to isolate a variable means to get it all alone, or it's the fancy way to say solve for x, like isolate x, because our goal when we're solving for x is to get it by itself. So, in order to solve for x, to get it all alone, to get rid of things that are around x, we have to use their inverse. So, an inverse is an opposite operation that will allow you to get rid of things with x in order to isolate it. And so we use inverses in order to solve for x. And because what it does is it gets rid of things. Well, the big fancy word for get rid of is eliminate. So you can also say an opposite operation that will allow you to eliminate things with x in order to isolate it. So these are the big fancy words that I'm going to use in this lesson. Moving forward, we have to talk about some math notation. So the word notation just means how we write stuff. So for example, when we look at x, what that means is that we have one x, because there's one of them right there. So even though there's no number in front, the notation is that if there's no number in front, it's a secret one because there's one of them. So if there's two x's, well, that means there's two x's. However, these two x's are getting added together. So if I had one x here and another x getting added together, then I would have two x's, which I can combine like this. But that's not all 2x means, because let's pretend x was 5. So 5 plus 5 equals 10. Well, what that's saying here is that if x is 5, if I go to this part, there's 2x. So 2x, but we were saying x is 5. So I replaced x with a 5. So when you look at 2x, that means you have two 5s getting added together because x is 5. And there's 2 in front, meaning there's 2 of them being added together. And we get the answer of 10. Well, what is this mathematically? What's happening to 2 and 5 right now? It becomes 2 multiplied to 5, because multiplying tells you how many times you add something to itself. So 2x means 2 multiplied to x, whatever that x is, because it means you have 2 of those x's getting added together, which is just multiplication. Because remember, multiplying tells you how many times to add something to itself. So 2 times 5 means take 5 and add it twice. Or it could mean take 2 and add it 5 times. But again, 5 2s, 2, 4, 6, 8, 10, it's still 10. If there's a number in front of the x, it tells you how many x's you have being added. Or it tells you that it's that number times the x, which is different. It's very different than an x squared. Because x squared, x to the power of 2, this is an exponent up here. So this math notation, it could be read in many different ways. So I'm going to write how we can read it real fast. So you can say x squared. That's the most common one. You can also say x with an exponent of 2, because a little number in the upper right-hand corner is called an exponent. You can also say x to the power of 2, because they also say like to the power of for exponents. You can also say x to the degree of 2. They all mean the exact same thing. It's just 4 ways to say it. But no matter how we say it, what it means is that it's an x multiplied to another x. Exponents tell you how many times you multiply something to itself. For example, let's say x was a 5 again. So I have 5 being squared. Well, that means I have 5 multiplied to 5, and 5 times 5 is 25. So remember, exponents tell you how many times to multiply something to itself. Taking my 2 rules here between the difference between the number in front and the number in the exponent on the little upper right-hand corner. I'm going to do it again, but this time it's with 3x or x with the exponent of 3. So remember 3x, when the number's in front, it means they're getting added. So there's 3 x's being added to itself, because that's what multiplying means. Multiplying tells you how many times to add something to itself. So for example, if x is 5, 3 times 5 is 15. Because if I have 3 5's getting added, 5 plus 5 plus 5, that's 5, 10, 15. Versus x to the power of 3, or to the exponent of 3. So here, there's a few ways to read this one. The most common way is to call it an x cubed. Little 3 means cubed. But we can also say x with an exponent of 3, or x to the power of 3, or x to the degree of 3. So there's lots of ways to read this one. But what it means is that we're going to take x, we're going to multiply it to itself 3 times. So for example, if x was 5, 5 to the power of 3, or 5 cubed, means it's 5 times 5 times 5. In the calculator, here I'll show you what 5 to the power of 3 is. It's 125. Because 5 times 5 was 25, times 5 again is now 125. So when you use the Desmos calculator, and you type math in here, remember what it equals is down here if you look where my little red circle is. And then for this second problem, this is where that answer is. It's right here. So that's some math notation of what it means exponents versus the number in front and how they're different. Which means when you look at this, it says 2x equals 8. What this is saying is 2 multiplied, because when there's a number right next to a letter like this, it means it's getting multiplied to that x. So 2 multiplied to some number is going to equal that 8. The 2 multiplied to what? What times 2 equals 8? Well, 2 times 4 equals 8. Because if I have 2 4s, 4 plus 4 is 8. But let's say I didn't know that. Let's say I didn't know my multiplication tables, and I don't know that 2 times 4 is 8. So I can't do it in my head. And I promise you there's going to be some that are much, much harder that you cannot do in your head. So if you cannot do it in your head, here's what you do. Since this is 2 multiplied to x, the inverse of multiplication is, what do you think the opposite of multiplication is? Division. So all division is backwards multiplication. So they undo each other. So if I have 2 times x equaling 8, and I want to solve for x, to get rid of something that's right in front of the x that's getting multiplied to it, to undo multiplying, I have to divide both sides by the 2 that's getting multiplied. And here's what happens. What is 2 divided by 2? 2 divided by 2 is 1. So when I divide that 2 away, I am just left with 1x now. So I don't have 2 x's there anymore, I just have 1x. And remember from what we were talking about earlier, 1x is the same thing as just x. So by getting 1x, I have x all alone now because there's just one of them. And it's going to equal on this side 8 divided by 2. So if I do 8 divided by 2, I get out 4. So even if I didn't know that 2 times 4 was 8, I could just use a calculator and divide the 2 away from the 8 to figure out that the x has to be 4. So that 2 4s equals the 8. So then I've solved for x. I know my answer is that x has to be 4. And this equation up here is 2 4s equal 8. One thing I'm going to point out really quick is that fractions just mean division. So like, for example, 3/4, if it's written like that, it is the same thing as saying 3 divided by 4. This is kind of what we use in elementary school, like this little division symbol. But in high school, most of the time you're going to see it written as a fraction like this, where the 1 on top is the first one, and then this means divided by this fraction line, and then the 4 on bottom is the second one. Just like here, the reason why I did the line right there for the division is because it's the more high school proper way to write division. So then 2 divided by 2 cancels and becomes just the 1x, and then 8 divided by 2 becomes the 4. So you always read them top down, and this is the notation for dividing. So this one, what happens with this one a lot is people see the negative and think, oh, it's minus, I should add it. And that's only sort of true. That would be true if I was -3 plus x, because now they're separate things separated by a plus sign that you can add over. Even if it said -3 minus x, well, now, again, it's like the -3 is one thing and it's minusing a different term, this x. And then so you could add this 3 over. But when they're connected, when there's nothing between them, it means -3 multiplied to x. You can kind of think of it like this, like there's a parenthesis around that x. And because they're being multiplied, to get rid of it, I don't add it over. How do I undo multiplying? By dividing. So I have to divide both sides by the fact that it's a -3. So now -3 divided by -3 will cancel and become just the positive 1x, but I don't have to write the 1. And it's going to equal 24 divided by -3. And that's -8. So x is -8. So the equation is -3x equals 24. But when I solve for the x, I got -8. So if I take this x and if I turn it into a parenthesis and put my answer in there, it's saying it equals 24, which is what the equation said it should equal. So I know I'm right because if I put my answer back into the original equation, the answer I get out should be the same as what it's telling me it should equal. And since it equals 24, like it says it should, we know we're right. All right, fractions. There's another notation note I should make. You see this type of fraction that says 1 divided by 2, or 1/2, 1 over 2? This is the same thing, where because it's still 1x getting divided by 2. You can write 1/2 like this, or you can do it where you do the x and just divide it by the 2. So no matter the notation, the rule works the same. The top one is what you're multiplying by, and then the bottom one is what you're dividing by. So 1/2 means multiply by 1, divide by 2. So this is saying half of something is 8. Half of what is 8? Well, if you take 16 and you take half of 16, half of 16 is 8. I'll show you in the calculator. Half of 16 is 8. So 16 is going to be my answer. But if I didn't know that, and I had to do the math, here's how you do the math. Whenever you have a fraction, to undo the fact that you're dividing by something, what's the inverse of dividing? Inverse of division is multiplication. So to get rid of divided by 2, I'm going to multiply both sides by 2. So what happens on this side is when I multiply it by 2, it can cancel with the fact that it's dividing by 2. Because the inverse undoes it, it eliminates it. So then I'm just left with the 1x equaling 8 times 2, and 8 times 2 is 16. Well, don't forget 1x is the same thing as just x. So I've solved for x now. And so I know x would have to be 16 because half of 16 is 8. So if I do another example, something divided by 2 is going to equal 5. Well, to get rid of the divided by 2 part, I'm going to multiply both sides by 2. Over here, the 2 on top, 2 divided by 2 will cancel and just become the 1x. And 5 times 2 is 10. And so x would have to be 10 because 10 on top, 10 divided by 2 is 5. All right. So this is a type of fraction that has a number on both top and bottom. Besides, these guys had ones up here, like this is a 1x, and this is a 1/2 x. But this one has a 2 on top and a 3 on bottom. So 2/3 of something is going to equal 10. Well, you're going to start with the fact that you're dividing by 3. And how am I going to undo dividing? I'm going to multiply both sides by 3. So then if I do 3 times 2, that's 6. But then if I divide it by 3, it just goes back to being 2x. So I'll show that again. I'll do it over here. If I have 3 times 2/3, well, I have to do 3 times the 2 on top, and that's going to give me 6. But then I still have divided by 3 on bottom. And 6 divided by 3 is 2. So really what happens is this 3 cancels with this 3 because multiplying by the division is inverses, so they eliminate each other. And then you're just left with the one on top, right here as your answer. So this 3 cancels with this 3 and they eliminate, and I'm just left with the 2x. That's going to equal on this side, the 10 times the 3 is 30. Now 2x means what? It means 2 multiplied to x, and how do you undo multiplication? What's the inverse of multiplication? Division. So I have to divide both sides by that 2. 2 divided by 2 is 1. So I just get 1x. It's going to equal 30 divided by 2, which is 15. So 2/3 of 15 is 10. Let me show you. If I have 2/3 of 15, look, the answer is 10. So 15 is the correct x. And so finally, this is 3x divided by 4. Note real fast, I could have written it like this, 3/4 x. Or I could have even written it like this, 3/4, and the x beside it. These all mean the same thing. It doesn't matter if the x goes up with 3. It doesn't matter if it's beside it like this. It doesn't matter if the fraction's written side by side or up and down. They all mean the same thing, which is why sometimes I wrote the questions like this versus sometimes I write them like this so that you can practice that they mean the same thing. So for this one to solve, what do you think my first step's going to be? Since there's a fraction that's getting divided by 4, I have to get rid of that first by multiplying both sides by 4. So this times 4 divided by 4 will cancel, and I'll just be left with the 3x that's left on top. And it's going to equal 6 times 4, which is 24. Now, how am I going to get rid of this 3? Well, you can divide it away because 3x means 3 times x, and the inverse of multiplying is dividing. So 3 divided by 3 is just 1x. They eliminate. And over here, 24 divided by 3 is 8. So the answer is that x would have to be 8 in order to make this true. So I had 3x over 4. And if I take that x and I turn it into an 8, the answer is 6. If they look here, that's what they want it to equal, 6. So I know I'm right. And that is how you solve for x when there are things being multiplied or divided to it. So using the vocabulary from this lesson and if-then statements, here I'll give an example this time. You might say, if there is a number in front of x, then it is being multiplied to x. And if we are multiplying something to x, in order to eliminate it, you have to do the inverse, which is division. And therefore, once you do that, x will be isolated. So I used all my vocabulary words when I did that, and I used a ton of if-then statements. So I explained one of them. Go ahead and try to explain that one again, the multiplication one, but also try to explain the division one too by yourself using if-then statements in the vocabulary.